Hello everyone, my name is Saili Kadam. In our previous video, we discussed decision tree. In this video, we will be talking about random forest. So let us get started. So basically, as we are studying supervised learning algorithms, again, random tree is a supervised learning algorithm, and it is simply the combination of multiple decision trees. So in our decision tree video, we discussed that we will start with the data set and we will split the tree based upon the features that gives us the best split. So we studied the working of decision tree in our last video very well. In this video, we will be discussing random forest, which is nothing but we could say that extension of decision tree. When we combine the results of multiple decision trees and come up with one result, that is basically random forest. Everything is same. Decision tree is simply like when we simply have one decision tree, and when we start with the data set and then we split that data set based upon the features, that is simply the working of decision tree. Random forest is when we combine multiple decision trees and we come up with one decision. So obviously for classification we will perform voting, and for regression we will perform averaging. So this is random forest, and we can use random forest for both classification as well as regression. So let us understand with the help of an example how exactly random forest works. So we are given with a question that if a student studies for 4 hours and the attendance of the student is 80%, what will be the result? That means whether the student will pass or we fail. So this is what we want to predict. So let us say we have first tree. First tree says or predicts that the student will pass based upon the data set given. Then the second tree says again that the student is pass. Third may say that the student is fail. And fourth one says that student is again pass. So here we will perform averaging. We will average. So out of 4, 3 of them say that the student is pass. So the tree or the random forest will predict that the student is pass. Let us understand how will it work for regression. So let us say again we are given the same data that uh, the attendance of the student is 80% and the number of hours the student studies is 4 hours. So how will it work for regression? Let us say the question is, this is the given data that 80% is the attendance and 4 hours is the number of study hours. How much will be the score of the student? This is what we are supposed to predict. So let us say that the first tree says that the student may score around 75%. Second says that 73%. Then the third says 72%, let us say. Then one says 74%. And again 75%. So if we have this, we will simply perform averaging. We will add all 5 of them and simply divide it by 5. So this is how it will work for regression. So for classification, we will have different categories that either pass or fail. We take first we decide the number of decision tree that we want. We will train each and every decision tree, and then we will perform voting for classification, and for regression we will perform averaging. So this is how simply random forest works. The working of random forest is very simple. It is nothing but combination of multiple decision trees. We take in decision tree, we simply have one tree. We have some set of features. We select which feature gives us the best split, and based upon that split, we perform splitting, or we reach till the leaf node. Whereas in random forest we simply take multiple decision trees, they have their individual performances, and for classification we simply perform voting, and for regression we perform averaging. This is how random forest works. So this is how random forest works, as we discussed right now, that we have a data set, we create multiple, so we split that data set, and then we have every decision tree is trained upon each data set. So basically, let us say we have 50 data points in the entries. Then we then we will perform feature selection. Feature selection, the concept of feature selection, and when I say that we create multiple random data set, these two are very important concept when it comes to random forest, which we will discuss shortly. And then the very last step, that is again, so that means we will train some decision trees first, and then we will perform voting for classification and averaging for regression. So these two are very important concepts, bagging and feature selection. So let us say I have a data set having 50 samples or 50 uh, data points. So when we try to train it, we have different samples. So let us say I have 5 trees. So all of them won't be trained on same data set, or they won't just have one data set and they will be trained on the same data set. No, all of these decision trees, they will be trained on a different data set. So that means the data set, we have entire complete data set. That data set is divided into multiple splits or multiple data points, and every decision tree will be trained on a different data set, and the training data points, they are selected with replacement. That is, let us say I have 10 data points and two decision trees. I am training two decision trees. So I can do one thing. Five, I split that data set into two equal parts, five for one and five for other data decision tree. So what will happen is, now this 5, there is no guarantee that the 5 data points for first decision tree and the 5 for second decision tree are unique. They can be repeated. So with replacement we can have, so this may happen that, let us say the second observation or the second entry and third entry, both of them are present in both training sets of first as well as the second one. So with replacement, what we do, we perform the training data is splitted into the number of decision trees that we have. So the data set gets splitted into that many parts, and that too with replacement. Then we have feature randomness. In decision tree, we used to carefully select the feature. There we just had one decision tree. So we used to select the feature that used to give us the best result, for which we used to use the Gini index and information gain. These were the two concepts that we used in decision tree. But here we don't have any such criteria. We randomly select the features and we randomly split those features. So these two are very important concept when it comes to random forest. Then a very important thing, when we are dividing our data set, we divide that in equal parts but with replacement. So there is a very high possibility that 37% of the data is not present in any training set. So let us say out of 10, only 7 or 8 of them are present in both of them. Two of them are not present in either of the training set. So this is basically, we call it as out of bag data, but here we use it for testing purpose. So the two data points, so 37% of the data which is not present in any training set, we directly use that for testing set. So we don't require any special test cases to simply test the performance of the model. We simply use the remaining 37% of the data for it. Then again, as every algorithm, even random forest has its own assumptions. So the first assumption is, uh, let us say in decision tree we simply have one decision tree. Whatsoever is the result of that decision tree will be the final result. Whereas when we have multiple decision trees, even if one decision tree don't perform well, or the other decision tree performs so well, but the result gets averaged. So the performance don't depend entirely on one split or one decision tree. So it basically thinks that when multiple weak learners come together, they can form one strong learner. This is how random forest, this is how the approach of random forest is, that when multiple trees, weak performers come together, they can come up with one best performer. This is what random forest works on, or this is what the idea is behind random forest. So the average gets, the result gets averaged, so the number of trees, as the number of tree increases, the result becomes better. And very important thing, that is all this tree, they are not related to each other, they are independent. Every single tree, it will have its own result. It won't, it won't rely on a previous tree, or it, the result is unique, result is independent of every single tree. Then uh, so it works best when individual tree are accurate but different from each other. So every tree will have to be different, so that is why we use a training set that is different for every single tree. So when individual tree performs well, automatically the performance of entire tree becomes better. So these are the assumptions of random forest. Then we have advantages. So when, as I said, that when we simply have one decision tree, the result will entirely depend on that decision tree. Whereas now we have multiple decision trees, so even if one decision tree don't perform well but the other performs so well, everything gets average. So result don't get affected by just not performing, not, if there is only one decision tree which is not performing so well, then the result won't get affected. Then again, very important thing, we discussed this already, that we can use this for both classification as well as regression. Then, as we just discussed on the same slide, that 37% of the data don't appear in any training set which we directly use for testing set, or which we directly use for testing purpose. So we don't need any separate validation set. From the given data set only, we can have the validation set as well, and it handles missing values so well. These are some of the advantages of random forest. Then the disadvantages are, as the size of data set increases, it becomes slow, because let us say we have thousands of data entries in one, only one set. So what will happen is we will have more number of trees, and even if we don't have more number of trees, processing this many data points is a very lengthy process, which makes this algorithm slow for large data set. And we use multiple decision tree here, which requires memory. So again, it is memory intensive algorithm. So these were some of the disadvantages of decision tree. Then we have applications. We can use this in stock market prediction, fraud detection, recommendation systems, and multiple such systems. So this was all about random forest. The working of random forest is very simple. That is, combine multiple decision trees, take their average for regression, and voting for classification. This is how random forest works. So that was all for this video. In our upcoming videos, we will be discussing further supervised learning algorithms, and also the important concepts that are very important when it comes to machine learning. So all of them we will be discussing in upcoming videos. So that's all. Thank you.